Let's talk about the Pythagorean identities. All right, so we're working with the unit circle, right? We know that any point on this unit circle, the x and y coordinates of any point on the outside of the perimeter of this unit circle, the x coordinate is the cosine, the y coordinate is the sine. Okay? Now, you see this right triangle here, right? And so you know by the Pythagorean theorem that if you have a right triangle and the sides are A and B and the hypotenuse is C, right? This is a right triangle. So hypotenuse is always the side opposite of the right angle. Then the Pythagorean theorem says that a squared plus b squared equals c squared. Okay, that's typically the way that you learn the Pythagorean theorem. But in this case, the two legs are x and y, right? And the hypotenuse is 1 because it's a unit circle, so the radius is 1. So by the Pythagorean theorem, x squared plus y squared is equal to 1. And because x is cosine and y is sine, then we have this nice little identity, beautiful little identity that cosine squared plus sine squared plus cosine squared is equal to 1. Sine squared of theta plus cosine squared of theta is equal to 1. Beautiful. All right. That's awesome. That's called the Pythagorean identity, and that's the main one that you need to know. All right. Now, there are actually 3 Pythagorean identities. It's good to know that they all exist. But I just remember this one. This is the key one to remember. And then you can easily come up with these other Pythagorean identities just by dividing either by cosine squared or sine squared. Okay, it's an identity. It has an equal sign, so we can do the same thing to both sides. So, for example, if I take sine squared theta plus cosine squared theta equals 1, and I divide both sides by cosine squared of theta. Okay, so that means that I'm going to divide everything on both sides by cosine squared of theta, right? Cosine squared of theta. Cosine squared of theta. So what I end up with, because sine squared over cosine squared is tangent, cosine squared over cosine squared is 1, 1 over cosine squared is secant squared, I end up with a new Pythagorean identity that says that tangent squared plus 1 is equal to secant squared. Okay? So I don't bother remembering that. I know it exists, but I just prefer to use the sine squared plus cosine squared equals 1, and then if I need it, I can. I always like to check myself because I always doubt my memory. I would rather use my reason to figure it out. So if I just remember one thing, that's much better than having to remember 3 things. So we can get this next Pythagorean identity in a similar way, except that we're dividing by sine squared, right? So you can see that if we divide sine squared by sine squared, we get the 1. If we divide cosine squared by sine squared, we get cotangent squared. And when we divide 1 by sine squared, we get cosecant squared. So you can see where that one comes as well, just by dividing both sides of that core highlighted Pythagorean identity, just dividing everything by sine squared. All right, so let's use that to do some problems here. So first of all, this example 6 is just asking us to simplify the simplify these expressions. Okay. So one thing to know is you can take that sine squared, and let me just copy it down here since it's not on the screen. Sine squared theta plus cosine squared theta equals 1. Okay, we can rearrange this too. I can write sine squared theta, and I can subtract cosine squared theta from both sides, and I get sine squared theta is equal to 1 minus cosine squared theta. Okay. So now you can see I can replace this numerator up here with sine squared of theta, right? Because 1 minus cosine squared of theta is equal to sine squared theta, and then it's divided by sine of theta. So this is just sine squared of theta is just sine of theta times sine of theta, right? It's just sine squared. And then we're dividing it by sine of theta, and one of those will cancel. So what I end up with is just sine of theta. Okay? So this expression here in part A simplifies down to sine of theta. All right, so let's take a look at this next one. Well, I see 1 plus sine here. Now I can also rearrange this sine squared plus cosine squared into 1 minus sine squared. So let's do that. Let's try that. I can rearrange this into cosine squared theta is equal to 1 minus sine squared theta. So I can replace that top. I can replace the numerator here with 1 minus sine squared of theta. Okay, and then I have 1 plus sine of theta. Just plain old sine, not sine squared. Just plain old sine of theta. All right, so remember, sine squared of theta is equal to just sine times sine. Okay, sine squared. So this is actually the difference of two squares. This numerator is the difference of two squares because 1 squared is 1, right? So I can actually rewrite this 1 minus sine squared of theta as 1 plus sine of theta times 1 minus sine of theta. Okay, just factoring the difference of two squares. And then that's all over 1 plus sine of theta. And now you can see the 1 plus sine of theta can cancel with the 1 plus sine of theta. So what I'm left with is 1 minus sine of theta. And that is equivalent to this expression that we had up here, cosine squared theta over 1 plus sine of theta. All right, so that takes some practice. So we'll have to do some practice on that. But, I'll meet you in the next video.